Today you'll be learning about nuclear fusion. Fusion is one of the ways that energy is released from the nucleus of an atom, and has many possibilities for the future. In fact, fusion is one of the biggest areas currently being researched today. Be sure to pay attention and fill out the supplementary worksheet that comes along with the video. There are two main ways that nuclear energy is released, through fission and fusion. Fission is a process whereby an atom is hit using a neutron, creating a new atom, another neutron, and releasing energy. This other neutron can go on to hit another atom, creating a chain reaction. Fusion is a different process whereby two atoms combine to make a bigger species, in the process releasing a larger amount of energy. We will be focusing on hydrogen fusion, whereby two hydrogen atoms combine to make a helium atom and a free neutron, as well as releasing energy. Hydrogen fusion naturally occurs in the sun, where the temperature is so hot that matter actually exists as plasma. This means that the electrons around an atom are actually physically removed from the atom itself because of the high energy of the electrons, resisting the attractions between the positively charged nucleus of an atom and the negatively charged electrons. What happens in hydrogen fusion is that two hydrogen isotopes, deuterium that consists of one proton and one neutron, and tritium which exists as one proton and two neutrons, combine to form an intermediate species consisting of two protons and three neutrons. This species is very unstable because of the neutron to proton ratio, so a neutron is emitted as well as a large amount of nuclear energy. The resulting products are a helium atom, a neutron, and a relatively large amount of energy. It turns out that nuclear fusion releases far more energy than nuclear fission. In fact, 2 to 4 more times more energy is released in a fusion reaction where two atoms are combined than in a fission reaction where an atom is split. Fusion may be particularly useful in the future because of how easy it is to obtain hydrogen. Hydrogen can simply be taken from water through chemical methods. It may also be transported as hydrogen gas, which has the formula H2, through pipes and then split up into individual hydrogen atoms at the fusion site. This way, as long as we have water, we will have a source of fuel. One of the problems that we encounter with using fusion on Earth is temperature. We need to make temperatures as high as the sun's temperature happen on Earth, which may be up to 5,778 Kelvin. There is also the problem of containing matter in plasma at temperatures this high, since many materials will melt or not be able to hold such hot matter. There is also the issue of safety. Hydrogen gas is highly explosive, so transporting it may easily result in a disastrous explosion. Another problem is energy efficiency. We don't quite know the net yield of energy since we need to take into account energy needed to reach such high temperatures, energy needed to store the plasma, energy needed to get hydrogen from water, energy needed to transport the hydrogen, and energy from energy conversion laws. In the end, how much energy do we actually gain? Another issue arises when terrorists get their hands on fusion technology. With it, they may be able to build better and more harmful weapons using fusion technology, or they may even use fusion to create heavier elements that are radioactive like uranium, and then use those in nuclear weapons. It's important to not forget that hydrogen fusion may also be very beneficial. Although fusion can be used to create heavy elements, hydrogen fusion in fusion reactors will only create helium, which is not radioactive. Thus, the waste products are not toxic and not radioactive, so they won't need to be stored underground like waste from nuclear fission reactors, which is radioactive. One key aspect about hydrogen fusion is that it's sustainable. As long as we have water, we'll have a fuel source. This can be used for a long time as 70% of Earth's surface is covered with water. This will not be nearly as detrimental to wildlife as fossil fuels and nuclear radiation from nuclear reactors are. There won't be any significant pollution problems, and not nearly as many habitats will be destroyed. Right now, chemists and physicists are working hard in developing nuclear fusion for use here on Earth. There have been rudimentary forms of fusion, but none as big as to power anything significant. The road for developing nuclear fusion is still long, and even when it is plausible to use, it will still have to face legislation and review by Congress.